Our second example starts on page 201. In order to collect information for a student survey, a researcher classifies students according to eye color, the options being blue, brown, green, gender, male or female, and class rank, freshman or sophomore. A folder for each classification is then made up. So for example, one folder is the freshman female green eyes folder. So before we go any further, let's make sure we understand what's going on here. We've got some sort of person making folders. Now, is there an equal number of people who have blue eyes versus brown eyes? No. Are there an equal number of freshmen and sophomore? No. But there will be an equal number of folders because she's putting who knows how many things in that folder, but there's one folder per combination of categories. So we want to know how many different outcomes make up the sample space being all the different folders. So if someone pulls a folder at random, how many folders are they choosing from? So before we try making another tree diagram, just pause the video and just give it your best hypothesis of how many you think there will be. It's okay if you're wrong. Just put a little bit of skin in the game, and you can compare to your answer at the end. So when we turn the page 202, number 8 has a tree diagram started for us. Just so all of our tree diagrams look the same, let's go in this order. Let's have our first category be the class. No, maybe. There we go. The class. So freshman and sophomore. And I think I'm going to put freshman on top, sophomore on bottom. Then let's let the next category be eye color. And then finally, we'll do male, female. So pause the video, fill in your table, and we'll join back together. So to finish up number 8, we want to come up with the sample space. Now you could write each final combination, freshman, blue, male. You could write it to the side right here of each branch, and just having your list right next to it, that's fine. That's a great way to write the sample space. Or you could write it with our set notation where we list it all out. So either way you want to do it, go ahead and it has a spot for it. Fill in your sample space. So I wrote all my sample space as a list down here, but you could have also just, it really kind of fits the space in the text better to list them going up and down. That way is fine too. So we guessed how many we thought there were. We can count them now. And 1, 2, 3, 4, there's 12. How'd you do? Let's look at number 9. We want to find the probability that one of the folders selected at random is a student with blue eyes. So how many total possibilities are there? The total goes on the bottom. Now, how many of these are blue? Well, let's see. Here's blue. So that means this one and that one. Or in other words, this one and that one. Or I could look in my list at the bottom, however you wrote your list. Blue, blue, and then this other blue coming from the sophomore branch. Blue, blue, that's it. So 4. You could write your final answer as 4/12. You could write it as 1/3. You could even write it as a decimal. You'd have to round a little bit, 0.33, or you could say 33%. An important thing to just remind ourselves, when we're finding the theoretical probability like this, it's important that every single option is equally likely. If every single option is not equally likely, we can't do it this way. We've got to do it a different way. But in this case, we're just getting one folder out of 12, or each folder is equally likely. It really is random, and so this method works. Number 10, we want to find a female without brown. So that could be, let's see, it could be a freshman blue female. Maybe, there we go. Let's see, this one is freshman brown, so female, we don't want that. My next female is freshman green female. Yep, that would work. Sophomore blue male, sophomore blue female. That works. Sophomore brown male, sophomore brown female, don't want any of the browns. Sophomore green female. Okay, looks like it's four out of 12. And those same equivalencies that we did on the last one totally apply. For our last example, for our last question on this example, number 11, we want to find the probability of a male freshman. So test yourself, pause the video, answer number 11, and then check and see if you're right. How'd you do? Did you get 25%, or 1 out of 4, or 3 out of 12? If so, good job. I went through and I circled which ones out of the sample space qualified. I also drew the path along the tree. And we look and see we've got 3 final branches.